Okay, so one of the things on your little quiz we're going to have in a few minutes is, do you know the vertex? I think you all are like, duh, it's right there. But do you know if it's 2, 0 or 0, 2? And here's a way to remember it. Would you agree that is called the y-intercept? Okay. And the y-intercept is where, and you should be able to fill this in for me. So like it's either 2, 0 or it's 0, 2. And the y-intercept is where what is what? I'm going to say that again. The y-intercept is where what is what? Well, the y-intercept is where x is 0. So it's definitely that one. Does that make sense to you? The y-intercept is where x is 0. All right? So it's that one. And I know most of you knew that that's 0, 2. All right? The next thing is there's an axis of symmetry. That's this dotted line that runs down the middle. And they're always the axis of symmetry. So they're always an x equals thing. So in this case, since it's right on the axis, you might realize that it's not at x equals 1, or here's like where x equals 5. It's not obviously over there. It's at x equals 0. And that'd be the axis of symmetry. All right. Can you be quiet back there, please? All right. So next thing is these guys, and they're called the x-intercepts. And the x-intercepts have y equal to 0. So I know it's got to be comma 0. And then it's just like, what comma 0? Well, this is 1 comma 0. And that one there would be negative 1 comma 0. And if you can just double check yourself, they're x-intercepts, so y is 0, see? All right. Now the next thing is coming from an equation. It's similar, but it's different. This is a special form of an equation called vertex form. And obviously 5 and 3 are involved in the vertex. Can you just write me what the vertex is for this? I'd forgive you for thinking it was 5 comma 3, but what is it actually? Negative 5 comma 3. All right, next thing I've reminded you is that these are all U-shapes unless there's a negative in the front. They're all U-shapes unless there's a negative in the front. So this guy's got a name. I said I'd only do that for one thing entire semester. I gave it a human name. What's its name? Max. So that kind has a maximum. Every other kind that doesn't have a negative, it's not a max, it's a what? Min. And to make sure you get what I mean, a U-shaped parabola that looks like this, that has a low spot, right? So that's got a minimum. A parabola like this, that's got a high spot, that's called a maximum. Okay, so it's either a max or a min. And the way you can tell from an equation is if there's a negative. All right, next thing, this is going to require you to actually multiply some stuff out. X plus 3, x minus 5. Would you please multiply that out? Because we want standard form, and this is called factored form. You've got to be able to multiply these puppies out. This has to be like breathing. You just do it naturally. Don't have to even think. But you do have to write, Sam. Let's go. I really think the loops help. You don't have to do them if you're like a pro. If you get these right every time, then ignore me. But if you're not getting them right every time, x squared, that one's negative 5x plus 3x minus 15. Final answer, x squared. I should have my y equals to make it an equation. If you don't have an equation, it's not, you don't have an equal sign, it's not an equation. Minus 2x minus 15. Raise your hand if you had that one right. Okay, awesome. Now, would you have been able to handle it if I stepped it up to 2x plus 1 and x minus 7? The only difference is that 2. Don't let it freak you out. 2 times x, 2x times x, sorry, is 2x squared. Go ahead and finish this one. I think you'll know what to do on all the other ones. You do that one next. So negative 14 plus 1 is negative 13. Very good. Keep going. Finish this thing off. Because we're taking it from what's called factored form to what's called standard form. Do you see a negative named Max in the front? No, then this one's got a minimum. It's got a low spot in the graph at the vertex. Now this form is not good for finding the vertex. This form is good for finding the x-intercepts, which we'll talk about in a minute. But multiplying it all the way out gets you 2x squared minus 14x, and then plus 1x, and then this last one is minus 7. 2x squared, these together make minus 13x. I already heard the kids saying that, and then minus 7. There we go. Now, other than dumb mistakes, like, oops, I multiplied it wrong, or oops, I subtracted wrong, or whatever. Are you guys getting it so far? Are you with me so far? All right, good. Then, last major thing that you have to know how to do, and tons of kids like get the easy one, and then they get the hard one wrong. Tons of kids, if I asked them what the x-intercepts are, they'd know that 3 was kind of a thing. Like, they knew 3 is in the answer. All right, well, the harder part is what the other one is. So I want to show you what you're really doing when you get 3 as an answer. You're saying, I want x minus 3 to equal 0, because this whole thing will be equal to 0. That's key on all your quadratics, especially when you get to the hard part of the test. Later on, when we get to the tests on this stuff, it'll be part of the trick will be setting it equal to 0. Because if you have a y there and y equals 0, you're finding the x-intercept because y equals 0. All right, so we're trying to make this equal 0. And 3 does it. See, if you put the 3 right here, it'll make it equal 0. So what makes this one equal 0? Don't try to guess and check your way to it. Most kids will be like, they'll get something wrong. They'll be like, oh, I know it's a fraction, and I know it's got a 7 in it, and it's true, but just make this little equation, and then you get the simplest little 2-step equation. That equals 0. Minus 7, 2x equals negative 7, divide by 2, negative 7 over 2. Why is that the answer? Because if I put it here, negative 7 over 2, these 2's would cancel, and then it will say negative 7 plus 7, which makes 0, and that's the whole point. All right, so my 2 answers for this were 3 and negative 7/2. But wait, there's supposed to be x-intercepts, and the alarm bell should go off in your head if you ever just write down a number 3. I've told you, that's too simple. Where you're at a higher level now. You can't just say 3. So if it's an x-intercept, the y is what? 0. So 3 comma 0. And if this is an x-intercept, then the y is 0 comma 0. Does that make sense? All right. That's almost everything. The last melody, the last thing that I got to teach you is if you have this, I know you're all going to know the vertex. We practiced that already. That'd be too easy. But could you multiply this thing all the way out and get standard form? Do it. I'm telling you, it's amazing. At least a third of the class is going to get this wrong. Like literally 8 people in here, maybe 10, are going to get this wrong. Because they're going to get confused on what they're doing. Or they're not going to be careful. Daniel, tell me how to start, because if you can start right, you'll probably do it right. So, what does that tell me to do? The exponent is correct. We're going to square this. So what does that mean I should do? Oh, so you think it's x squared plus 9, because that's what squaring each of those would mean. No. No, that's not how it works. If you mean to write x plus 3 and another x plus 3, that is what you're supposed to do. Tons of people will do this x squared plus 9. It doesn't work. It's not right. Because squaring really means timesing by yourself, and that's got 4 parts, not 2 parts. It's got 4 parts to the answer. All right, so that was the most common mistake. And here's the final answer on this one. X squared plus 3x plus another 3x, and then the 3 times 3 at the end, plus 9. And then I'm bringing down this minus 1, and then the last thing you would do is put those together. Now, I know some of you got that right, and that's fantastic, but can you do it when there's one more step? Because there's something called a scale factor. You didn't want this class to be super easy, did you? So can you do it when there's a 7 there? Give this a shot. For those that are like, well, that's just too hard, Mr. Server. It's really just one extra step. You just got to times all of this stuff by 7. And the minus 1 just waits till later. Notice I'm starting with the white stuff there. And then I'll times it all by 7. Let's see if Mr. Server can do it in his head. This is not easy. Final answer. After I did this in my head, I'm going to have 7x squared plus 70x. And then this 5 times 5 is 25, and 25 times 7 is 175. And then I haven't done the minus 1 yet. 7x squared plus 70x plus 174. I think that's right. Can anybody verify they got the same thing? Yay. Okay, now I have only one new thing to teach you today that you've never seen before. And I'll teach you this once today, and then I'll review it again tomorrow, because this is not super easy. It's not incredibly hard. Think of this as a mountain that you had to climb up. If you were thinking about climbing up this mountain, would you agree you start on the left-hand side? We have to fall back on what we do as in America when we're reading the English language. It goes from left to right. You might just assume that everybody goes from left to right. Actually not. There's several languages where you read from right to left. All right, so we read from left to right. Would you agree there's some times when you're going up the mountain and it would be kind of hard because it's, steep? And there's other times when it goes downhill, and then that would be relatively easy, although actually, honestly, you end up when you're going down a mountain, it actually can be kind of hard if it's really steep and you're going downhill, because it works different muscles on your legs. If you've ever actually done a hike like that, the downhill part isn't actually incredibly easy. But anyway, there's times when you're going up, times you're going down. So here's the math thing we ask. We ask, is this function increasing or decreasing? And this one is both, because sometimes in this part here, it's increasing. In this part here, it's decreasing. And then in this part here, it's increasing again. Now, if it was that easy, if you could just draw it on the graph, oh my gosh, everybody get it right. It's increasing in the blue, it's increasing in the yellow, and only in the little red zone there was it decreasing. But the reason it's hard is because you have to write it in intervals. And let's see if you can handle this. This blue interval here, from there to there, it was increasing from negative infinity, which is like saying way on the left, until it stopped increasing right there at the top, which was at, I'm going to be careful and write out the point. That was the point 0, 1 right there. And you're always using x values. I get how it seems like you might say 1 right there. It's increasing until 0. It's like, where does this blue line live? At 0. Where does this blue line live? I could have actually started it way infinitely to the left. So it's negative infinity to 0. This spot right here, if I was flipping a coin between 2, 0 and 0, 2, I might just write it out and then ask myself, it's an x-intercept, so the y is 0. Okay, cool, I did it right. And you're always going to use x numbers. So for this interval here, that where it's going down, that one where it's going down, you're going to say from the x numbers, from 0, because that's the x number, that one's the x, to 2. It was decreasing. In here it was increasing. And then it increases again in this zone. And the way you would say that is from 2, because that's the x number, to what lives infinitely way over there? Positive infinity. Negative infinity lives way over there. And these are only about the x numbers. So now, if I said this function was increasing in here, decreasing in here, and in this part it was increasing again, then I did it right. On this, you can always just use parentheses. Don't even think about using brackets on this. Because the argument would be if you got to the top as it's still increasing at that second that you get to the top. And so we just, actually there's some books that allow parentheses and some that allow brackets, and so I'm okay with either. But I want you to use parentheses because that's what our keys are going to say. Use parentheses on these things. All right, so here's a super easy one now. Here's a parabola. You've seen them a million times. Is it increasing sometimes? Yes. Some kids think it's increasing all the time because they're like, I see arrows going up. But in this zone, if you were walking it, it would be going downhill. That's decreasing. You go from left to right, that's decreasing. DEC. This part here, I'll use a different color. That part is increasing. It's going up. So how would I actually write my answer? Would you do it, please? Remember, it's the x values, and the only point that's really important is 0, 0. The vertex. Right there. Zane, what lives way over here? And what lives way over here? Yes. What lives way to the left? And what lives way to the right? On the X. And I don't think you understand my question, which I understand. Negative infinity lives here. And what lives way to the right? And those are going to be in your answer. Those are x. And we're only supposed to use x values. All right. So it decreased from here to there. And only use the x numbers. Negative infinity to 0. Who had figured that out? All right, not that many people. How about the increase? Use the x number, 0. When does it stop increasing?
Never.
So therefore,
It's infinite.
infinity. That was increasing from 0. When does it stop increasing? It started increasing right there, stopped increasing, well, here at infinity, as in it never stopped. So that's infinity. All right, if you're still not getting this, I understand, these are tricky. Here's another one of our classic functions. That's x to the third. If you were walking this from left to right, isn't it always increasing? I know there's that one spot in the middle that's kind of like a trick spot. Did it ever decrease?
No.
No. It just kind of like changed how fast it was increasing. It was kind of slowing down and then it just kept going up. Like if you actually had to walk that, do you agree it's going up? Yeah, it's going up the whole time. So, how do you say the whole time when you're talking about the x? Yes.
Negative inf to inf.
Yep. Negative inf to inf. I like it. And that's fine. It's actually good because on the Schoology quizzes you have to write INF. So you're right. Negative inf to inf. All right. That was increasing always. All right. One last one. Think of it as a mountain. And this is the point 3, 2. I know I was a little loose with my graph there, but remember, this is only about x values. So I would name here and here because they're going to be used in your answer. And then I'd say, when was it increasing? And you can always put in parentheses and a comma every single time. When was it decreasing? Parentheses and a comma. And I know some of you are going to get confused because you're like, I think I'm naming a point. Nope. I'm telling you the x values of when it was increasing. It's not a point. It looks like a point. It's not a point. All right. So this is where negative infinity lives. This is where infinity lives. It was increasing in here. So when did it start increasing? Negative infinity. When does it stop increasing? It does stop increasing right there. Always use the x value. Negative infinity to 3. Raise your hand if you had negative infinity to 3. Oh, good, you're getting it. Decreasing. The only time it's decreasing is from 3 to it never stops. So, infinity symbol. Okay, there's the new thing for today, which is about increasing and decreasing. It is on your test. It is that simple. It's a question a lot like this. They're not super complicated. You just have to remember it's x values, and you have parentheses and a comma. All right. So, now the little quiz that covers all the stuff I just reviewed. It does not have anything of the new stuff. And so, on the back, I'm going to have you make 2 increasing, decreasing questions. And those you have to do yourself at home to practice what I just showed you. Literally 2 problems for at home. The whole rest of the hour is you working with a partner that I assigned to take this quiz. All right. And that's all I have for you for the video for today.